Well, welcome to another video from Physical Science. In this video, we're going to be discussing solar eclipses, or eclipses in general. So an eclipse is basically when one orbiting body moves in position where it's just in front of the other orbiting body. It eclipses it. So a solar eclipse is when the moon gets in between the sun and the earth, and it completely blocks out the sun's light. So here you have what I'm talking about, where the moon, now this is a new moon position here. Okay, that's a new moon. And the new moon is casting a shadow on the earth because it's positioned itself just perfectly in between the sun and the earth. Okay? So the sun, or the moon, which is casting a shadow, the darkest part of the moon, okay, the umbra, that's where you're going to see. Now, if you're at the right spot on the planet Earth, you're going to get a total solar eclipse. That's going to completely block out the sun's light. And this is what the view is going to look like from Earth. Now, if you're not in the perfect spot on Earth, you could be somewhere else, higher or lower on the latitudes. You're going to get the penumbra. Okay, that's still casting a shadow. That's still an eclipse, but it's going to be a partial solar eclipse. And the reason for that is because some of the light from the sun is still able to angle itself out, so it's not going to be quite as dark as people positioned in that narrow part of the Earth where you'll get a total solar eclipse. And those sites on Earth are usually the sites where the scientific experiments are conducted to see the atmosphere of the sun, which we'll speak about later. I don't know if you can hear the lightning in the background, but it's pretty cool. Anyways, let's continue on. So this is the situation for a partial solar eclipse. You have the sun, the moon in between the earth, and now we're going to take a look at a lunar eclipse. Okay, so again, this is a solar eclipse, and now a lunar eclipse. Take notice how the earth is now in between the sun and the moon. All right, so let's look at the dynamics that come into play for a lunar eclipse. So here you have the umbra, just like you do with the solar eclipse. You have the umbra, which is the shadow that's being cast by the earth. And you'll notice that the moon is right in that shadow. And then, of course, you also have the penumbra. Now, the difference between the lunar eclipse and the solar eclipse, as far as getting the best view of it on Earth, is that with the lunar eclipse, it is visible anywhere on the dark side of the Earth. Unlike the solar eclipse, where you have to be in a really narrow area of planet Earth to get the best view of the solar eclipse, the solar eclipse. Now, the lunar eclipse, as you can see, there is no limit as to where you need to be on Earth to get a good view of this phenomenon. So the Earth will cast a shadow, and the moon will pass right over that shadow. Keep in mind that the moon this is in a full moon phase. Now, the only difference is that in a full moon phase, that the moon is not actually in the shadow of the Earth. It's actually above the shadow, so it doesn't really have an effect on it. But with the lunar eclipse, again, the moon's path takes it right into that shadow, so it blocks the sunlight. Now, it does not block it completely because, as you can see, the moon does have some coloration. And this color, this reddish color, as a result of the Earth's atmosphere. Now, this phenomena you see it every day play out every evening when the sun sets. And the reason why it looks red is because as the light bounces off the atmosphere, it gives off that reddish hue. Okay? And so that reddish hue that bounces off the Earth's atmosphere lands on the moon, and it gives it that blood red color. Okay, so if you're on the surface of the moon, the Earth will look essentially red because that's the color that's coming off. Now you got to keep in mind also that the color of the sun itself is not actually yellow; it's white. That's the color of sunlight. That's the full spectrum, the rainbow spectrum that I discussed in other videos. It just so happens that the light that's traveling from the sun to the Earth, the full 8 minutes that it takes. And once it hits the Earth and it hits the atmosphere of the Earth, the light's bouncing all over the place because of the nitrogen and such in the atmosphere. and it kind of gives us that yellowish reddish color that we see, that we recognize as the sun color. But in any case, so this lunar eclipse phenomenon, this color, this reddish color, comes from the Earth's atmosphere. Okay, and then you can see here that the moon is slowly moving out of the Earth's shadow, and it's getting its full moon color again. Okay, so that does it for eclipses, the two types of eclipses, and I hope this video helped, and good luck in your studying.